Hey guys, this is a video for significant figures. So we want to see when we calculate something how accurate we can get. And we do that by finding its significant figures. So to start, significant figures are just the digits within a number that tell you how accurate it is. All right, it's going to tell you how confident we are when we are either measuring data or gathering data from graphs. There are 5 rules for determining how many significant figures there are in a number. So, rule number 1, all numbers that are not 0 are significant. So if we look at this guy, we have 1, 2, 3, 4, 5 non-zero numbers, 5 sig figs. Rule number 2, any zeros in the middle of a non-zero number are significant. So 2.003, these zeros are between non-zero numbers, a 2 and a 3. Therefore, we have 4 significant figures. Rule number 3, zeros after the decimal are significant. If we look at this one, because there is a decimal here, we count all of the numbers after it, zeros and non-zero numbers including. So here we have 1, 2, 3, 4, 5 significant figures. Rule number 4, any leading or beginning zeros are not significant. So in this number we have down here, because we are starting with or leading with 0 numbers, they are not significant. So we don't start counting until we get to this 8 here. And once we do count the 8 and 2, we have 2 significant figures. Rule number, here's another example. Again, we have a lead 0, so we do not include it. So the ones we do have are 2, 3, and 5. And one more. Starting with 2 zeros this time, we do not include these when counting how many significant figures we have. We have the 9 though, 0, and 7. So that's 3 significant figures. Let's go to rule number 5. Zeros in a large number without a decimal are not significant. Okay, so if we look at that, we have a large number here. We do not have a decimal place, meaning we do not, these zeros we have here, we are not going to count as significant. And if we just look, we actually only have 1 significant figure. Okay, because this is the only non-zero number that starts the number. Now for rule number 4 and 5, I'll get to that in 1 second. Another example, right? We have a number without a decimal, so that means only these 2 numbers are significant. All right, so there's this rule or this guide that can help you solve. Notice how rule number 4, we were counting at the end of the number, right? And then rule number 5, you're counting to the left of the number. So how can you figure out when you're counting to the right and when you're counting to the left? Well, it has to do with whether or not there is a decimal present or absent. And for that, we can use this kind of helpful Atlantic-Pacific rule. This is a thing I use all the time still to this day. I learned this when I was in high school, and it's been, you can still use it no matter how far into chemistry you get. But basically the Atlantic-Pacific rule, we want to, it's A or P. Is the decimal present for Pacific, or is the decimal absent? So if the decimal is present, say we have a number like this, we start on the Pacific side, right? Because the Pacific Ocean is on the left side of the United States with the first non-zero and count to the end. So we are counting this way, right? So we start 1, 2, 3 significant figures. Right, Pacific to Atlantic. We go left to right, right? Pacific to Atlantic because the decimal is present. Present for Pacific or Pacific for present, however you want to think about it. We can see the example here as well. 1.25, we count from Pacific to Atlantic side. If the decimal is absent, we start from the Atlantic side, which is going to be right to left. Right? So in this example, we do not have a decimal. The decimal is absent, so we go from Atlantic side to Pacific side. So we have 1, 2, 3 significant figures here. So the key to this is to find if the decimal is present or absent, and once you know that, it'll tell you which way to go. All right, so you can use that guide to kind of help you for those rules number 4 and 5. And then we also need to find significant figures when adding and subtracting. And the rule for this is look for the least number of decimal places that you're adding or subtracting. And a good way to do this is to line them up. So for the first problem, we have 5.08 plus 823 plus 321.3. So we can just round them or line them up by decimal place. All right. So we see we don't have any decimal places here. So our answer, once we round to significant figures, is going to be to this spot. You do that addition and you should get 1,149.43. But remember, we're going to the least number of decimal places, which is going to be right here. Then, when we're rounding, we have to look at the previous number to determine if we round up or down. If it's 0 through 4, we round down. 5 through 9, we round up. So in this case, we have a 4, so we're rounding down. And that number will just stay as 1,149. Okay, that is the correct number of significant figures based off of this problem. Second one, we have 4.245. So I'm just going to go ahead and line them up by decimal place. Next one I have 8,023.1. And the last one is 34.21. So I'm going to line it up based off of this guy. This is how far I'm going to go for my final answer. You can always just solve for the number, find the lengthy number, and then get the significant figures after the fact. So if we add all of this up, we should get 8,061.555. Now we need to round to significant, which is going to stop right there. So our number now is going to be 8,061 point. This is where we have to decide if we round up or down. This is a 5 before it, so we are rounding up. So this is 8,061.6. And that would be our answer. All right, so for adding and subtracting, look for the least number of decimal places. All right, so when finding sig figs for multiplying and dividing, we actually want to look for the least amount of sig figs. Okay, so I always recommend solve the problem, and then from there, determine the sig figs of each number that you began with, and whatever one has the least amount of sig figs, that's what your answer is going to be. So for example, this problem right here, we have 24.5 times 63.2751. 24.5 has 3 sig figs. 63.2751 has 6. Again, when multiplying or dividing, we were looking for the least amount of sig figs. So our answer is going to be in 3 sig figs, because that is how much detail we can present or show based off of our numbers that we were given. So we calculate this and you get 1,550.23995. We have to go to 3 significant figures here. So 1, 2, 3. So we have to make sure that After that number, it's not significant. And to do that, we just make it into a whole number without the decimal, right? Because now we have the decimal absent, so we go from Atlantic to Pacific when counting how many significant figures we have. So we have 1, 2, 3 sig figs. All right, let's do one more. 31.5 divided by 89.21. Again, count how many significant figures each one has. This one has 3. And 89.21 has 4 sig figs. So again, our answer this time is going to be in 3 significant figures. If we just put it in our calculator, we get this long number. And we need to, again, go to 3 sig figs, because that's the lowest number we have, or lowest amount of sig figs that we have. So that's 1, 2, 3. So then we determine if we round 0, that's rounding down. So our answer is 0.353, which is 3 sig figs. All right, so there are some practice problems down here. And if you want, just take a second, see if you can get how many. You can pause the video and figure out how many there are, and then we'll go over the answers. So number 1, we only have 1 sig fig. Right? No decimal. The decimal is absent, so we have to go from right to left. This is our first non-zero number, so 1 sig fig. 80.20, that is 4 sig figs. Right? The decimal is present, so we go from Pacific to Atlantic side. We start counting when we hit our first non-zero number. 1, 2, 3, 4. 3 is 3 sig figs. Right, we're going from, our decimal is present again, so we go from Pacific to Atlantic again. Start counting when you hit the first non-zero number, which is right here. 1, 2, 3. Number 4, 9.32 times 10 to the second. So this is a scientific notation. There will be a scientific notation video to talk about that, but we basically just count these 3 numbers for 3 sig figs. And number 5, we have 4 sig figs, right? Because we have a decimal present, so we go from Pacific to Atlantic, left to right, until we hit that first non-zero number, which is 8 in this case. All right, let's do some adding, subtracting, dividing, multiplying. So number 6, if you want, instead of lining them up, kind of a thing that I would do, I mentally just kind of check to see which one has the lowest, and that's how far I'm going to go once I find my answer. So this has 2 decimal places. This is to 4 decimal places. This one's to 3. So I know my answer is going to have 2 decimal places, or 2 numbers after the decimal place. You add that up, put it in your calculator, and you get 895.2753. Again, we want to go to this number. We want to round to that number, and the 5 is going to have us round up. So we're going to rewrite that as 895.28. Next one, 42.12 minus 21.9. So we can see right there, this is to the 2 after the decimal place. This is 1. So our answer is only going to be 1 decimal place after. And we do that subtraction, we get 20.22. We need to round this, right? Because this is how accurate we can go based off of this guy here. And the 2 here is going to tell us to round down. So that's going to be 20.2. Number 8, multiplication, 0.124 times 9.009. You put that in the calculator, you get, let's see, 1.117116. Then we check how many significant figures each number has. This one has 3 sig figs. This one has 4. So we know our answer is going to be in 3, right? Because that's the lowest amount. So 1, 2, 3. And the 7 is going to round the 1 up. So our final answer will be 1.12. Last problem, 21,000 divided by 0.00144. You put that in the calculator and you get this really big number. I don't even know, 145,833.33. Okay, so then you need to find how many significant figures we started with. This one is 2. Right, it's a whole number, there's no decimal, so we go right to left. And this one has a decimal present, so we go left to right. This one has 3 sig figs. So our answer is going to be to 2 significant figures, and which will go right here. And this 5 is going to tell us to round up. So our final answer once rounding is 1, 5, and then just a whole lot of zeros. 1, 2, 3, 4, 5, 6 zeros. Right, because I'm just taking these numbers and we're just rounding them down to 0. All right, so that's our final answer. Right, it's got 2 sig figs. There is no decimal present. All right, so that's just a few examples. Just remember when you're doing these, any leading or beginning zeros are not significant. And zeros in a large number without a decimal are not significant either. Okay, remember that Atlantic Pacific rule? It's also a little history lesson or geography lesson, so that's helpful for 2 classes. I hope this was helpful. Let me know if you have any questions. Bye, guys.